In this video, we're going to solve absolute value inequalities. Now, these can be tricky. You should have experience in solving absolute value equations. You should also have experience solving inequalities. Combining them both in one problem will require some skill. The first thing we do when we're solving an absolute value equation is we write two equations. So when we're solving an absolute value inequality, we'll write two inequalities. We'll use the same procedure that we did with absolute value equations. We replace the absolute value symbols with parentheses, and we're going to put a negative sign in front of one of the parentheses. This is a very important step, because if you solve it this way, you don't have to learn any new rules. All the rules that you learned for absolute values apply. All the rules you learned for inequalities apply. You have no new rules to learn if you do it this way, replacing it with parentheses, putting a negative sign in front of one of the parentheses. It may look like more work, but there's nothing to memorize. Then you're going to solve the two new inequalities as usual. But be careful, because there's a negative sign in front of one of these, you're going to have an issue with dividing an inequality by a negative. So please remember this rule. And the rule is not a new rule, it's an old rule. When you divide or multiply an inequality by a negative, you reverse the inequality symbol. I should have written divide or multiply. When you divide or multiply an inequality by a negative, reverse the inequality symbol. When graphing, the result is either going to be two graphs that are going in opposite directions, or one interval where the two sides are coming together, bounded on both sides by a number. You'll see this in a few moments. So what we're going to do is we're going to try a couple basics, and then we're going to work on a harder problem. But it's important that we illustrate what the basics will look like. So here, using the procedure, we're replacing the replacing the absolute value with parentheses, and we're just copying everything else. On one set of parentheses, I just leave it as is. In the other parentheses, I put a negative sign in front. So this is obvious. X is less than 2. Here, I need to divide both sides by -1. And when we divide an inequality by a negative, we have to reverse that inequality symbol. Now, if you were to graph this, you would see that x is bigger than -2. Here's -2. Or x is less than 2. So we'd actually be bounded. We're less than +2, but bigger than -2. Here's an example of being bounded. Let's try this other one. On this inequality, for example, this previous one we had the absolute value being less than 2, so being that absolute value has to be a positive number, there's only a limited range of numbers that can result in an absolute value being less than 2, and once we solved it, that's all the shaded region in there. Here the absolute value must be greater than 4. There are lots and lots of numbers that are going to be ending up bigger than 4. But let's solve it using our procedure. We have parentheses instead of the absolute value symbols is greater than or equal to 4. That's one inequality. The other one is the negative parentheses is greater than or equal to 4. And so we're going to, again, this is just the absolute value is greater than or equal to, x is greater than or equal to 4. That's going to be pretty basic. Here we have to divide both sides by -1, and we get x is less than or equal to, remember we reverse the inequality symbol, -4. Now when we graph this one, here we have -4, here we have 4, x is greater than or equal to 4. So we're going to shade bigger than 4. Or x is less than or equal to -4. We're going to shade to the left of 4. So these go in two different directions. I'm calling that divergent, and these are convergent. They're going towards each other. Let's put this into practice in a longer problem. This is going to take a little bit of work, so we'll work quickly. We'll just change this to parentheses. 2 times the quantity x minus 1 plus 4. This is all the quantity in parentheses is less than or equal to 8. That's one equation, or one inequality. The other one will be the negative quantity, 2 times the quantity x minus 1 plus 4, and that quantity is less than or equal to 8. Now instead of distributing that negative, I'm just going to get rid of that negative right away on this side by dividing this entire thing by negative 1. So we'll end up with 2 times the quantity x minus 1 plus 4 is greater than or equal to negative 8. I'm supposed to be dividing that by negative 1. Let's do the both problems sort of in a parallel fashion, because whatever we do to one, it's going to have a very similar effect to the other. So here we're going to subtract 4 on both sides. Here we're going to subtract 4 on both sides. We end up with 2 times the quantity x minus 1 is less than or equal to 8 minus 4 is 4. Over on this side we have 2 times the quantity x minus 1 is greater than or equal to negative 8 minus 4 is negative 12. And I could divide both sides by negative 2, divide both sides here by 2. I get x minus 1 is less than or equal to 2. Over here, x minus 1 is greater than or equal to negative 6. Lastly, we're just going to add 1. X is less than or equal to 3. And here, x is greater than or equal to negative 5. So I hope you see we're going less than a large number, bigger than a small number, so we really are going to be bounded together. And again, it's because the absolute value was less than a number, which meant we're really limited as to the range of values that are going to be less than or equal to 8. The absolute value is going to be less than or equal to 8. So let's see what this would look like on the number line. Here we've got a negative 5. Just for the sake of time, I'm just going to graph negative 5 and 3. You could put 0 in there if you're interested. X is less than or equal to 3. Bracket at the 3, shade to the left. X is greater than or equal to negative 5. Bracket at the negative 5, shade to the right. And here's my graph. Finally, let's write the interval. The interval is going to be bracket, negative 5, comma, 3, bracket. And that's the end of the problem.